Hello and welcome. If you've been watching any of my videos before, you've probably seen me use all four of these words on the screen, and you've heard my definitions for each of these words. Why don't you take a minute now and review, write down in your notes what you think the definitions are of sum, difference, product, and quotient. All right, so I trust you just pause the video and we can move on here. So the definition of sum is the output value from the operation of. That's what all of these definitions are, right? They're all output values. So sum is output value for addition, difference output value for subtraction, product is output value for multiplication, and quotient is output value for division, right? So if I have an example here, say 3 and 4, I would say the sum of 3 and 4 is 7, right? Or 7 is the sum of 3 and 4. Or I could say the difference, 3 minus 4, that's going to get me -1. Notice subtraction is not commutative. The sum of 3 and 4 is the same as the sum of 4 and 3, but the difference of 3 and 4 is not the same as the difference of 4 and 3. So you have to be careful about which order we're stating that difference in. Product here, I could say 3 times 4. Right, the product of 3 and 4 is 12, or the quotient of 3 and 4 is 3/4. Again, multiplication is commutative. The product of 3 and 4 is the same as the product of 4 and 3. The quotient of 3 and 4 is very different from the quotient of 4 and 3. So we tend to use, because of that commutativity, we tend to use the sum and the product language much more often in casual conversation, right? What's the sum of these numbers? What's the product of these numbers? And maybe it's more than 2, right? We've talked about how to deal with that in past videos. But there's another way that we use all 4 of these words, and that's in a more, slightly more abstract sense, right? When I say 7 is the sum of 3 and 4, I'm using this definition. But I will also use the word sum. There you go. To describe the whole expression. I talk about this expression, 3 plus 4, as a sum, as opposed to this expression, which is a difference. Right? If I'm talking about the sum, I'm talking about the value. If I'm talking about a sum, I'm talking about the expression. And the same is true for all these other ones as well. So to talk about difference, that could be a mathematical expression whose primary or only operation is subtraction. Product is an expression whose primary or only operation is multiplication. And same thing for division. Go ahead and make sure you put those definitions in your notes. Pause the video if you need to. Okay. So one way we make sense of that isn't talking about algebraic expressions. If I look at something like, I'm just making this up on the spot here, 3x minus 4y plus 7 plus 2x. No, right? The structure of this problem is a sum, right? I'm getting the sum of these 4 terms, and that's the primary structure that we look at in most algebra classes, most high school algebra or basic college algebra classes, right? Before we get into the theoretical math major kind of stuff. We're looking at sums. Polynomials are sums of multiple terms. Another possible expression is something like this. There we go. Right, with parentheses next to parentheses, that means multiply. This is a product. And if I multiply that out, let's say we're in a pre-calculus class, we know how to multiply these, and we would get a sum, we would get a polynomial in some form. But seeing it in this form is actually really useful for different things. Both versions of an expression are useful. For the primary viewers of this video, we're not really focused on polynomials or graphing in that sense. We're looking at things like this, and maybe evaluate that if x is 4. So I'll go ahead and erase. Where's my eraser? All right, I'll just overwrite it here with where I say x was 4. It's times, not minus. Right? So what is the primary operation here? Well, I've got a sum, so I have 2 terms here. I've got division built in here. I've got all the different operations. This expression number 3 is not clearly a blank type of expression, right? And we see those all the time too. Not every expression is easily categorized into one of these 4 categories, but a lot of times it is. A lot of times we only have one operation, or we have one primary operation, as in examples 1 and 2. But we also see this as being really useful for making sense of word problems. So let's look at these one at a time. Isaiah picked out 11 books from the library, and Josiah picked out 8. Maybe I should just leave this down. Second question, Isaiah picked out 11 books from the library, and Josiah picked out 8. Right? That scenario does not tell us whether we're dealing with an addition problem or a subtraction problem or anything else. It's the question that actually tells us how many books do they take out altogether. That language tells me I'm looking at a sum, right? I'm looking at the number of books Isaiah picked out plus the number of books Josiah picked out. And then I can substitute in there. Isaiah picked out 11 books and Josiah picked out 8 books. So altogether, that's 19 books in total. Okay. Or you could ask, how many more books did Isaiah take out than Josiah? I'm saying Isaiah picked out more. I'm going to subtract the number that Josiah took out because I'm literally finding the difference, right? That's the third definition of subtraction, is to find the difference between 2 values. And I already know that Isaiah picked out more. That's what the question is saying. How many more books did Isaiah pick out? So I'm going to start with Isaiah, that's 11, minus the number Josiah picked out, and 11 minus 8 is 3. So I would say Isaiah picked out, I-S-A-I-A-H, picked out 3 more books than his brother, than Josiah. Right? Okay, it's the wording of the question that's telling me, is this a difference problem or a sum problem? And only once I know the structure am I going to then plug in the values, right? Third question, for every 1 book Isaiah picked out, Josiah picked out 3. That's a rate. If Isaiah picked out 6 books, how many did Josiah pick out? So I want to know how many Josiah picked out. And it says for every book Isaiah picked out, Josiah picked out 3. So Josiah's books, the number of books Josiah picked out in this scenario is 3 times the number of books times the number of books Isaiah picked out. Right? If Isaiah only picked out 1, Josiah picked out 3. Isaiah took a second book, Isaiah got 3 more. Isaiah picked out a third book, Josiah picked out 3 more. Right? If Isaiah picked out 6 books, that's going to be 3 times 6, right? 3 for the first, 3 for the second, 3 for the third, and 3 times 6 is 18, right? So Josiah picked out 18 books. The structure of this problem is telling me that it's a product situation. And lastly, Isaiah climbed the stairs to his house 3 at a time. So let's draw in some stairs here. Right? He's going 3 at a time here. So 1, 2, 3, 4, 5. I didn't draw enough. 6. So if I wanted to draw a staircase 14 steps high, I could just draw this and not really use an operation. I'm literally just counting. But if I want to avoid that, I can use division. I'm just taking this 14 and splitting it into groups of 3. That's our definition of division. You're taking the total and dividing that by the size of each group. And that will give you the number of groups, right? Groups of 3 steps each. How many of those 3-step groups does he need? So we've got 14 divided by 3. I'm saying 14 divided by 3. This is not part of my expression. That's how I'm going to calculate. So 3 goes into 1 0 times. 3 goes into 14 4 times, because 3 times 4 is 12. But then I get a remainder of 2. What does that mean? It means if I take 4 groups that are each 3 steps, that's going to get me 3 times 4 is 12 steps. But I'm trying to get to 14 steps. Right? So that doesn't mean he can't reach the top. It means his last step is going to be a little bit shorter than usual, right? This 14 is counting steps. This 2 is counting steps. That 2 can't be split up into a group of 3 by itself. So it's going to be a short step at the top. So it's actually 5 total steps. And his last one will just have to be shorter. Right, so it's kind of a cheating situation here, but when we're dealing with remainders, that's often the case. You can't say 4 and 2/3 groups. You can't take 2/3 of a step. You're just taking one step that's shorter than the other steps. And we'll get into long division with mixed numbers in a later video, in a later week. All right, so we've got a division expression here, a multiplication expression, a subtraction expression, and an addition expression. And all of those are word problem examples of these other definitions of our sum difference product and quotient.